Welcome, guys. Welcome to Legacy Solutions. This is your host, Ephraim Leo, and this video is about arrays part 1. So now an array can be seen as a container of data. That can be seen as a container or something that has a set of data in it. You can store it there. It can be any particular type, though all must be related. It can be integer, floating point, string, or character. It can be used to store data. It can be accessed later anytime it's needed, as I said earlier. And you make sure that the data you're storing are related. It cannot be different data or different type of data. Now, there are different types of data. We have one-dimensional arrays and we have multi-dimensional arrays. We have the 2, 3. It can be any amount you want. It just depends on the amount of data you intend on storing. It can be any amount at all. So now a syntax is the way an object or a program is being arranged. If you don't arrange it that way, it will lead to errors in your code, like in an array. It has its own arrangement. If you don't follow it, it will definitely lead to error, and it will lead to misinterpretation of your code by the computer system, because your computer will see it as a normal variable, meanwhile you are trying to process it like an array. It will give you an error. Because to see it as a variable instead of an array. Now you can define or identify an array. When you see it, you know that is an array. You can see it as the way here, which is the storage class, data type, the array name. In your square brackets you have the subscript, or you can call it elements. For example, you have this array here of an integer data type here. You have a as the array name, and then you have 80 elements in square brackets. There are also other ways of defining an array, though that subscript must always be from 0 to infinity. It must be an integer number, that is not a decimal number, not a floating point number. Not being a floating point number, it must be an integer. Now you have different ways of defining an array. You can define it the way it is stated earlier, but you can also define it as a storage class followed by data type, followed by the array name, but then you have your square brackets empty. This time around you won't specify the number of elements, but you can specify the elements you want in this empty square brackets. So you specify those elements and then it is assigned one by one into this place. For example, you have this integer here, a, with empty square brackets. You assign 3 as the first, 5 as the second. That's how it's assigned. Now if you have not specified the array size, but now because of this you specify it on your own. For here, for instance, this one, you can specify the storage class followed by data type, the array name, and then you specify the array size. Then you still be the one to assign that element into this your square brackets, which you just see as a container, something that you can put data in it, so you can use it or access it later on. Now, for example, you have this way. If you see a difference here, this one has no number of elements, but this one has number of elements. If you have this 3, 5, and 6, it means there are 3 elements in this array. But based on our zero-based indexing here, as you have 3 elements here, number of elements as 3, and then you have 3, 5, and 6. The last element, because of our zero-based indexing, which will start from 0, 1, 2, 3. As a programmer, you have to learn how to count from 0, 1, 2, 3. You don't count normally. You count from 0 to 9. Now imagine you have this here. It means that this will be 0, this will be 1, this will be 2. So what happened to the 3? Well, that will be backslash 0. That will be what will be assigned at the end of each of that array. But then when you have 3 elements here, and then this exceeds the number of elements, maybe you have 3, 5, 6, and then 7, you won't expect that 7 to be shown. It will be cut off because it can only contain 3 set of data. It can only contain this 3, 5, and 6. But then you put more than it, it will cut off those other ones because it is not needed. And then you have this here as your empty brackets, means this will be 0, element 0, this will be element 5, and so on. That's how it is. But then if you notice, this one has a limited number of array elements that you can specify, while this does not have. That means you can specify up to tens or hundreds of array elements. Doesn't matter, it's empty, so you can accommodate a large number. Now this here, it's the array name here is B, 3 elements, and then 3 here. If you don't specify 3 elements here, it means that the elements that will be in this place, the last one will be assigned by default to 0. So you have 3, 5, and 0 if this 6 was not here. You get? Alright, so when you want to process an array, you process it using a for loop, a while loop, a do while loop, any loop. Just make sure it is done on element by element basis. It's not like a variable that you have to process everything once. It has to be on an element by element basis. You can't just go that like a normal variable. So you start element 0, process it, element 2, element 1, process it. That's the way you process the elements. You can call any element from anywhere you want to call. It all depends on you, but just make sure it is done on element by element basis. You store data on a specific place in an array. You have to access it with a for loop. You don't access it ordinarily. Now it must always be processed on an element by element basis. You have to remember that. Use your operators, equal to, plus, increment operator. You know them. Yeah, all you just need to know is just know that you have to iterate over the array element by element basis. You have to remember that when you're working with an array. Now, to pass an array to a function, the array name must appear by itself without brackets or subscript. It must be defined within the function call and the main function. Normally everything will be shown in the code editor as we go into the main business of the day. Alright, here's our code editor and we can kickstart. Alright, so let's begin with our examples here. Let's say we have int a, say 3 elements. Alright, so we'll use a for loop. Alright, now for you to use a for loop, you need a counter or something that you can use to iterate over the array. It can be anything, but I use count because it's my favorite. It helps me to remember that I'm using a counter. I like it that way. You can use I, you can use anything at all. This is my choice. You have your own choice too. Just make sure that variable is not a word or a particular word that has been used by the people generating this program, like people that created this program. It should not be it should not be a reserved word. Alright, so let's see, count less than 3, count. So the count to increment after each iteration by 1. So now I'll just make a simple program here. Our count starts from 0. That means this count that I wrote now is indirectly 0. So now for an array, we make use of it like this. So now we have this. We can't just start from a, count 0, and then a1 count plus 1. You can also do that, but it's stressful. A1 count plus 1. It's actually stressful. I tell you that it's going to increment the count by 1. But then instead of it to do that, you can just change everything to count to make your work easier for you. Say you have this count is 0. Let's assign it. That means this count that is 0 here means A0. That means the first element of this count. I hope you understand. A0. That means that A0 that we wrote that time, that is what it is now. So for the second iteration it will be 1, and then we have A1. That means the second element of the iteration. Then we put our assignment operator there. That is, I wrote it this way to make you understand. So it carries the 0 here and puts it into the 0th element. That is the first element. For the second iteration, it counts that one, put it into the 1st element, count it, put it into the second or the 3rd element in the program. So that's it. So now print. Let us print our value. Let us see what we have here. Compile and run. Remember, we just started, so it will take a lot of time to compile. But since it's the first time, that's why it takes a long time to compile and run. But subsequently, it will take shorter time. Alright, you can run. Let's finish compiling. So now we run our program. We have 0, 1, 2. So that's what it does. It takes that first account as 0, assign it here, second iteration, that's how it is. So it prints the answer. Yeah, you can also put this printf account outside, but you have to write another for loop again. Understand? So that's how you do. That's how you do it. That's how you work with an integer that way. You can also move the values from one place to another. You can just make sure that you use a for loop. Just make sure you use a loop, because a do while loop, any loop at all. Just make sure it is done on an element by element basis. Now we need another for loop. So go. Same thing. So in this case, let's make all the elements of the array to be the same number. That is, you assign each of them to each of them. So let's just begin with making or assigning the last value to the first. Okay, this is the last value A, but now because of our zero based indexing, we are starting from 0, so the last element will be 2. We are starting it to the first one, which is 0. So let's print our result. Compile and run. No errors, so can run. You have 0, 1, 2, 2, 1, 2. I can make it clearer for us to understand. \n. Right, let's run. Okay, 0, 1, 2, 2, 1, 2. You can see here that the 2 that was here is now the first in this second iteration. Okay, now let's see if we can make all of them be 2. to 222. Now we have moved the last element to the first. So what about we move the second element, or let's say, okay, since the last element is the first, it's still the last element. So say, or let's go this way, A0. Since now your A0 is 2, and then we have okay, A1, we assign it to A2. Let's compile and see what it gives us. Zero, 1, 2, 2, 2, 2. So you see, that's how you move those elements into different parts of the array. Okay, let us try to assign some values instead of working with our iterator here. Let's assign some values to the array. So now we have A3, and we are assigning 1, 5, and 6. Alright, so I don't think we need this. Still need our for loop, but now we don't need this count here. All we just need to do is to print the answer. So let's compile and run. One, 5, and 6. See, so you can put those values in your array and access them with a for loop, with any loop at all. You can use a while, a do while loop, and all the rest. I'm going to make use of the do while loop in subsequent sections, but for this one it will be only the for loop because it's more basic, it's easier to understand. You can make use of it easier than using a do while loop. You use a do while loop or a while loop when you are working with strings. That is when you work with do while loops better. So that's not all. You can have empty brackets, empty square brackets, and you can put any amount of elements you want. But at the end of the day, you still need your number of elements at some point. Alright, so now you have 1, 5, 6. The others are not printed. Why? Because we reduced the number here to less than 3, so it will print only 3 elements. Then imagine we increase that value for iterator to the 6 values here. Increase it to 6. Let's see. One, 5, 6, 7, 8, 7. See, complete values. So that's the idea with an array. You just have to know how to work with your loops. So that's all for integers. You can use an array with with a float, but then make sure your count here, that's your iterator, the variable you use, is an integer. It's going to be easier for you to access. It's going to be easier for you to work with an integer counter or iterator variable. But when you're working with an integer, you can use a float. Since if we use a float and then we change the format tag to %f, save and compile and run. One point, you see, that's what happens when you work with a float. You have decimal numbers 0.000 attached to the end of the number if it's just an integer number, but then you can also reduce that number by adding, or let's say add 0.2, that is to 2 decimal places. So you compile. Now after it has successfully compiled, I don't think there are errors yet. That has successfully compiled, you can go ahead to run your program. You have 1.00, 5.00, 6.00, 7.00, 8.00. So that's how you reduce the number of decimal places. You can also increase the spaces between them by increasing this \n. You can add any amount of \n you want. It all depends on you. So you're the one programming, you're the one that knows what you want. So that's all for integers. Don't think there's any more basic thing to introduce. That's it. Alright guys, thanks for watching. This is Legacy Solutions. Don't forget to subscribe, like, hit the bell for post notifications, share for us. We love you all. Thank you very much and see you next time.